get to know the series, you need more examples, more techniques. So again, we continue with they are all in 11.2 that we've been working on. Okay, that concept of the series. So what I did the other night, I just give a geometric series. Okay, geometric series, telescopic series. And now I'm going to give you a new group. This new group is going to be called P series. Okay, that's a P series. So what is going to be a P series? If P is going to be, this is it. If P is a positive number, is a positive, it's going to be a fixed number, positive number, then this series, sigma 1 over, okay, n to the P, n from 1 to infinity is going to be called, okay, it's called a P series. A P series. Okay, so if P is equal to 1, for example, if P is equal to 1, then sigma of 1 over n, n from 1 to infinity is going to be a P series. When n is equal to 1, this is very popular. So it's going to be called, okay, sigma of over n is, you know that this is going to be kind of 1 plus 1/2 plus 1/3, etc. This is also called the harmonic series. Harmonic series. It's a very popular series, and it's going to be related to the, you know, to the music instrument, and you get this harmonic. You can search it for yourself, and you get quite a lot of idea. Okay, so that gives us a group of series examples that would be very popular. So we can check to see where this power series is going to be convergent. Okay, the proof, there are different ways to prove it. So we are going to prove this one later on for you. Okay, when you get to the 11.3, but they are going to be useful. So we give you the theorem, you can use it, and later on we give you a short proof. Okay, so this is going to be the theorem that you can apply to see where a P series is going to be convergent or it's going to be a divergent. Suppose, remember that the P is a fixed number. Okay, there you are, very easy test. If this P is going to be a number bigger than 1, this P series is convergent. Okay, P series is going to be convergent. If P, of course, P is a positive number. If P is going to be less than 1, less than or equal to 1, this series is going to be divergent. Okay, so there you are. Very easy test. The P series. Sigma of 1 over n to the P, NP, is convergent. Convergent, okay, if P is going to be greater than 1, and divergent otherwise. And is divergent otherwise means if P is going to be less than equal to 1. Of course, you know, P positive, because if it's going to be negative, you move it up, and the limit of the n-term test would be infinity. So in that case, that would be divergent. So if it's a P bigger than 1, this series is convergent. If it's going to be less than equal to 1, this series is divergent. In particular, harmonic series is divergent. Okay, because P is equal to 1. So in particular, the harmonic, okay, harmonic series, sigma of 1 over n is divergent. Very famous one among the divergent series. Okay, so you can use it anytime you like. So for example, this is it. We want to determine, okay, determine if the series, okay, is convergent or divergent. Convergent or divergent. Okay, so this is it. Just give a couple of them. For example, the first one is sigma of 1 over n squared. You see, this is a p series. P is equal to 2. It's greater than 1, so it's convergent. Okay, so the solution would be, you explain it that it is a p series with p equal to 2, which is greater than 1. Okay, it converges, or it is convergent. So we're going to explain it if it's going to be on the test or any quiz. You have to explain it's a p series, p equal to 2, bigger than 1, convergent. Done. Okay. The next one, sigma of 1 over radical n. And always, is from 1 to infinity when we don't write it down. You know that radical n is n to the half. So the solution, you rewrite it, sigma of 1 over radical n is sigma of 1 over n to the half. Again, is a p series with p equal to the half is less than 1. Since it's less than 1, is because radical n is n to the half. Okay, n to the half, so the power is less than 1, so it is going to be divergent. Okay, it's very, very useful series. Okay, give you another one. You see this one from time to time, so let's make a note. Sigma of 1 over n radical n. N times radical n. Again, when I don't write anything, I mean n from 1 to infinity. Okay, let's see what type of series is going to be this one. You know that radical n would be n to the half. N to the half times n. Okay, so note that. You see, note that you have 1 over n radical n. It's going to be 1 over n times n to the half. When you multiply with the same base, you add the exponent. So the power is 1, and this is 1/2. 1 and 1/2 would be 3/2, 1.5. So it's going to be 1 over n to the 3/2. 3/2 p is bigger than 1. Okay, so there you are. See that the sigma of 1 over n to the 3/2. 3/2 is a power series, is a p series. Is a p series with p equal to 3/2 greater than 1. So the series converges. Okay, so sigma of 1 over n radical n is a convergent series. Okay, so this is the way, this is the way we operate to get the divergent or the convergent series. Okay, so now we have the 3 groups of series that you have. Okay, you have geometric series, you have the p series, and you have the telescoping series that we're going to have. Okay, now what else can we do in this section? We are going to have operation with this series. You see, operation, I mean addition, subtraction, multiplying by a number. The multiplication is tricky, so we are not going to consider the multiplication. Okay, So it's like a sequence. You know that the sequences you're just using limit to find whether the sequence is going to be convergent or divergent. You know from calculus 1 that the limit of a sum of two functions is the sum of their limits. So if you translate it to the case of the sequences, this means if two sequences, an and the bn, happen to be convergent, their sum, a plus b, a and b like bn, their sum differences are going to be all convergent. So you're going to have the same thing for the series. Remember, if you want to do anything with the series, you have to find the sequence of the partial sums. So this theorem would be very helpful. So we make more convergent series theorem. So this theorem will give you operations, okay, operations with series. Very useful theorem, very useful one. Okay, the first one. The first one is that if you multiply the terms of the series by a number, or you divide it, okay, if the original series is convergent, the result would be convergent. If the original series is divergent, the result would be divergent. Okay, so this is going to be the one. So this is it. If sigma an is a series, and let's say k is a number. K is a number. Then you see sigma of an, the given one, and sigma of k times an. So if you multiply all the term of the series by a number, so both of them are going to be the same as each other. It means both of them can be convergent, or both of them is going to be divergent. Okay. So then sigma n and sigma bn are both convergent or divergent, or divergent. So this basically means, okay, if you want to another format, so this means sigma of an is is convergent if and only if sigma of k times an is convergent, is a convergent series, if you like, or is convergent. Okay, the same thing. Sigma an diverges if and only if sigma of kn diverges. Okay, so this means if you multiply the terms of the series by a number, the result would be unchanged. Means if the original series is convergent, this new one is also convergent series. Okay, if the original one is divergent, this new one would be divergent. Okay, so it would be very, very useful. This is one property. Second one, addition and subtraction. If the series, okay, or just say if sigma an and sigma bn are convergent series, both of them convergent series, then this series, you see, the series sigma of, the sum of the series sigma of an plus sigma of bn, which is equal to the sigma of an plus bn, or the difference. Okay, so if sigma of an and bn are convergent, then the sum of the series or the difference of the series is also convergent, is also a convergent, a convergent series. Okay, so this basically means the sum of convergent series is convergent. Okay, and easy to prove because the limit of a sum of two sequences is the limit of the first one plus the limit of the second one. The first one is convergent, the second one is convergent, so the sum is also convergent. Okay, so this is the case. The only general property. Okay, so I was cut off. So let's see what we did. We continue. Okay, so we're here. So we talk about it that the sum of two convergent series is convergent. You don't have any general result for the sum of two divergent series. You cannot say that the sum of two divergent series is going to be divergent. But we have one general result that would be useful, and we are going to use it from time to time. And this is the case. The sum of a convergent series and a divergent series. So if one of these series is going to be, suppose the first one is convergent, the second one is divergent. So the result is a divergent series. So the sum of a convergent series and the divergent series is divergent. Okay, so there you are. If sigma of an converges and sigma of Pn diverges, then their sum, sigma of An or the difference, doesn't matter, is a divergent series. A divergent series. Okay, so the sum of a convergent and the divergent is divergent. You don't have anything else general for the divergence. And it's very easy to prove. Because if this is going to be convergent, you see if sigma of An and the Bn is convergent, you see An plus Bn is convergent. An is also convergent, you subtract it. If you subtract the An and the Bn would cancel out, that gives you sigma of Bn must be a convergent series, which is not. Okay, so sum of a divergent and the convergent is divergent. Because if it's going to be convergent, you get two convergent, you subtract it, you get the Bn must be convergent, which is not possible. Very popular results. Okay, so to give you an example to see how we're going to operate with these. Quite useful, quite useful. So there you are. This is going to be an example. We want to check, determine whether the series converges or diverges. You have to give us a reason, remember. On the test, don't just say convergent. Say convergent, why? Why it's convergent. Okay, there you are. Just give you a list here. The first one. The first one, sigma of 1 over, say 1 over n cubed. N from 1 to infinity. Okay, you know that this is going to be a P series, P equal to 3, bigger than 1, so it's convergent. So this is the way you're going to answer it. Solution. Okay, so you're going to claim that it is a P series with P equal to 3 greater than 1. So it converges. It is convergent. It is convergent. And you're done. Okay, we talk about it. It's if the power is going to be bigger than 1. So that gives you the case. Okay, that's the first one. The second one. The second one is this one, sigma of 1 over n. 1/2 to the, okay, 1 over n, 1/2 to the n minus 1, n from 1 to infinity. Remember, it's a fixed number raised to something. It's geometric series. A geometric series with the common ratio of 1/2. 1/2 is less than 1, so this is convergent. Okay, so it is. It is a geometric series. You can write a couple of terms if you don't believe it. It's a geometric metric series. Remember, in the case of geometric series, we have a common ratio with r equal to the 1/2 and it's less than 1. So it converges. It is a convergent series. Convergent series. Okay, just remind you those that the one that we used before to get these numbers. Okay. Give another one. Okay, the other one is going to be sigma of 1 over root n, cube root n. You know that this can be written as what? Solution. Sigma of 1 over cube root of n is the same as the sigma of 1 over n to the third. It's a P series. P equal to the 1/3. Less than 1, it's divergent. Okay, so it is a P series with P equal to the 1/3 less than 1. You know that the P series, if the P is less than 1, it's divergent. It diverges. So that give you a series. Okay. Another one. Another one is this one, sigma of 1 over 5 times n. You see, this is one, if you pull out the 1/5, look at this one, solution. This is the sigma of 1 over 5 over n. If you put out the 1/5 outside, that gives a sigma of 1 over n. So sigma of 1 over n is a harmonic series. Remember, it's harmonic series, or the P series with P equal to 1 is divergent. And we talk about it. If you multiply the terms of the series by a number, which is a 1/5, resulted series would be also divergent. Okay, if the original one is divergent, you multiply by a number, this would be divergent. If the original is convergent and you multiply by a number, it would be convergent. Okay, so you explain that sigma of 1 over n is the harmonic series or P series, harmonic series, and is divergent. Divergent. Okay, so sigma of 1 over 5n diverges. We talk about it. If you multiply or divide by a series, both series means 1 over 5, sigma of 1 over 5n and sigma of 1 over n. Both of them are going to be divergent or convergent. Since this is divergent, so this series is also divergent series. Okay, so to give you an idea, you see, I told you the other day that you need practice. You need practice to be able, as soon as you see the series, you connect it to this known one that we talk about it, and then you will get your result. Okay, so these are the warm-up. So what is going to be the actual one we get? Look at this one, number 5. This series, sigma of 1 over n squared minus 1 over n to the third. You see? Is the difference between two series. One of them sigma of 1 over n squared, the other one sigma of 1 over n cubed. You know that both of them are p series. P, the power is bigger than 1, so both of them are convergent. And the difference of two convergent series is also a convergent series. Done. This is the way you explain it for us. You have to explain nicely. So the solution is going to be, we're going to say that sigma of 1 over n squared, p series, is a p series with power p equal to 2 greater than 1, and it converges. It converges. Or it's a convergent series. Okay, likewise, sigma of 1 over n cubed is a p series, with p equal to 3 bigger than 1, it converges. And you know that the difference of two convergent series is convergent. So we can simply say that therefore the given series sigma of 1 over n squared minus 1 over n cubed converges, or it's a convergent series. And then you that. Okay, this is how you are going to use those theorems that I talk about it. The difference of two convergent series is convergent. So you have to explain it. You see that you just put them, you break them into different parts, and then you explain what's going to be those partials that we're going to have. Okay. So let's have another one. I'll give you all the possibilities. You see this one. The other one is this one. How about the sigma of, you have 1 over n minus 1 over 3 to the n. Let's see, and you know, n is going to be from 1 to infinity. You see, it's the difference of two series. The first series, sigma of 1 over n, is harmonic series. It's a p series with p equal to 1. Harmonic series is divergent. The second one, sigma of 1 over 3 to the n, 1 over 3 to the n is what? Is geometric series. Fixed number is 1/3. With a common ratio of 1/3, 1/3 is less than 1, so it's convergent. So the first one is divergent. The second one is convergent. We talk about it. The sum or the difference of a divergent series and a convergent series is divergent. So this series diverges. So this is how you explain. Sigma of 1 over n. You can say harmonic series, and it diverges, or divergent series. Okay, sigma of 1 over 3 to the n, geometric series, a geometric series with r equal to the 1/3, common ratio less than 1. It converges, or it's convergent. So one of them divergent, one of them convergent. So the series, therefore, the given series, okay, therefore, sigma of 1 over n minus 1 over 3 to the n is a divergent series. Divergent series. Okay, so all the theorems that I talk about it, you can use them nicely to answer these type of questions that we're going to have. Okay, so if you have two convergent, the sum or the difference, both of them is going to be convergent. But if one of them is a divergent series, the other one is a convergent series, so the difference is going to be what? The difference is going to be a divergent series. Okay, so different format. I give another one. You see, this is also popular. Sigma of 1 over 2 to the n minus 1 over 3 to the n. You see, both of them are geometric series. So the first one is sigma of 1 over 2 to the n, geometric series, common ratio of 1/2. 1/2 is less than 1, so it converges. The second one, sigma of 1 over 3 to the n. Sigma of 1 over 3 to the n is a geometric series with a common ratio of 1/3. Less than 1 is convergent. And the difference of two convergent series is convergent. Okay, so this is how you answer this one. Solution is going to be what? So this is the way you explain it. So sigma of 1 over 2 to the n, a geometric series with the common ratio of r equal to the 1/2 less than 1. Okay, it converges. So the first one is a convergent series. Okay, the second one likewise. 1 over 3 to the n. Okay, again, a geometric series or just geometric series with r equal to 1/3 less than 1. It converges. And the difference of two convergent series is convergence. Okay, therefore, sigma of 1 over 2 to the n minus 1 over 3 to the n converges. So when it's the difference or the sum, it depends. If both of them are going to be convergent, your result is a convergent series. If one of them is convergent and the other one is going to be divergent, so it is going to be, okay, so it's going to be a divergent series to get the numbers. Okay, so this is, now you have a collection of all the series so far to be able, to answer it. Okay, so I'm going to give you another list and just to how you're going to check so far the series is going to be convergent or divergent. Okay, so remember what we know so far. So what we know so far, let me just I forgot to give you that list, but I'm going to give you that if I can bring it here so that you can see it. I had it somewhere. Okay. No, I cannot find it. But I find it and just I post it for you because we need more tests. There you are. Let's see. You see, suppose a group of series would be given to you and you want to check whether they are convergent or divergent. So far what we know the geometric series, we know the telescopic series, and we know the P series. Okay, so this is how we're going to check. And you have a list. I will post another one for you. Just go over that practice. Okay, the practice test that we have. just go over the terms of the series and the sequences for you, but I wanted to give you a hint before that, okay? So suppose this is going to be the case. You want to determine, okay, determine if the series converges or diverges, Okay, so this is the way you're going to check it. The first one, for example, is going to be sigma of, okay, sub sigma of 1 over n squared. So you just check to see what type of series is this one. This is a P series. P equal to 2 bigger than 1, so it's convergent. Done. Okay, so this is the way you are going to answer it. You say that sigma of 1 over n squared is a P series with P equal to 2 greater than 1. So it's convergent. It is a convergent series. Convergent series. With that. Okay, that's the first one. Let's check the second one. Second one is this one. Sigma of 3n plus 1, okay, over 2n plus 7, n from 1 to infinity. You see this series? It's not a P series. It's not a P series. It's not the geometric series. It's not the telescopic series. Telescopy is the one that you break it. So what else can you check? Remember, we talk about the n-term test. So the n-term test means you take the limit of the general term. Okay, limit of the an. Remember, we talk about it, give you divergent test. So if this limit is going to be a non-zero number, the series is going to be divergent. If that limit happened to be 0, you can't say anything. Okay, so we're going to check it. Okay, so we did check for the geometric, it's not. We did check for the P series, it's not. It is not telescoping, so far you go with these general terms, if you like. The n-term test or the divergent test. So what's the divergent test? We take the limit of the an when n goes to infinity. So it's going to be limit of, okay, limit of what? Limit of the 3n plus 1 over 2n plus 7 when n goes to infinity. Remember, we shrink it into the 3n on the top, 2n on the bottom, n goes to infinity. The n's would disappear. So that give you 3/2 is not equal to the 0. So the series is divergent. Okay, so the series diverges. It's the one we call it divergent test. And it would be useful for this group. Divergent test, you cannot use it for convergent. If you take this limit and the limit happen to be 0, you cannot say anything about it because I proved the theorem for you. But if it is not going to be 0, you can say that this is divergent. Okay, so very good test. Remember it. Okay, so the other one is going to be the group that we talk about it. Okay, so the difference that we did check. Okay, something like 1 over n cubed minus 1 over 5 to the n or plus. This is sum of two series. The first one is P series, P equal to 3, greater than 1, convergent. The second one is a geometric series, P equal to the R equal to the 1/5. Less than 1 is going to be convergent, and the sum of two convergent series is convergent, okay? So the solution is going to be sigma of 1 over n cubed. You can say that, you know, a geometric, a p-series. A p-series with the power p, 3 bigger than 1, it converges. This is the way you explain it on the test, remember. Okay, and the second one, sigma of 1 over 5 to the n. And this is going to be a geometric series, okay, with common ratio r equal to a fifth, which is a less than 1. It converges. So your series is a sum of two convergent series. Sum of two convergent series is convergent. So that's it. So sigma of 1 over n cubed plus 1 over 5 to the n converges. And you're done. Okay, so you get to know them as we go on from now on, and you understand, you understand the series, and then you'll be fine to get these series. Okay, so from now on we are going to introduce more tests for you. So I just briefly give you this idea because this is very, very important. This operation with the series. So now you have everything that you need to be able to take care of that practice. Okay, that practice.